Hey class, welcome back. This is lesson 11-5 where sure enough we're going to be finding the volumes of pyramids and cones. So we've already found the surface area of pyramids and cones. Now we're going to find the volumes of pyramids and cones. This is actually our last day on pyramids and cones, and then next class we're going to go to spheres, and then we're going to review and test. So let's talk volume of a pyramid. Remember that the pyramid has one base at the bottom, and then all the lateral edges go up to a point at the top. So what we're going to see, this is actually similar to the prism formula. Remember that BH that was in the prism formula? Well, this is similar, except now we're going to add in this 1/3. So the volume of a pyramid is going to be 1/3 the product of the area of the base times the height. So it's almost like we cut out 2/3 of the prism, right? Everything goes to a point, so we cut out 2/3 and we're left with 1/3 BH. I want you to remember that 1/3 because it's going to come back later. So here is the Louvre in Paris, France. This is a square pyramid. Remember, square pyramid means there's a square at the base, with a height of 21.64 meters. I want you to notice over here in kind of hard to see writing, it does say that the edge of the square is 35.4 meters. So what we're asked to do is find the approximate volume of the Louvre pyramid. Now we're going to use our volume formula. First thing we need to do is find the area of the base. That's going to be 35.4 times 35.4, which gives us about 1,253.16 meters. I think you can do that easily enough on the calculator. Next, we go in and we find the volume of the pyramid. So we do volume equals 1/3 times base area times height. Remember, this is a pyramid. So when it comes to finding volume, we need to multiply by 1/3, then base area times height. We're going to plug in our numbers. Remember, the base area was 1253. The height was 21.6. And if we multiply all that out, we get approximately 9,039 meters cubed. Again, remember, this is a volume chapter, or volume section, I should say. So our measurements are going to be cubic units, not square units, not just units, but cubic units. Let's look at another pyramid problem. So in this case, we want to find the volume in cubic feet of a square pyramid with base edges of 40 feet, so notice 40 feet down here, and slant height of 25 feet. So there's a problem here. We don't have the height. We need the height, but we don't have it. We only have this slant height. So what we're going to do first is find the height. We can do that using the Pythagorean theorem. Notice that the height and half the base edge, because we're going from the center to the side, are the two legs. So h is one of the legs, 20 is the other leg, and 25 is our hypotenuse. That's this longest side right here. Notice it's across from the right angle. The right angle almost points to it. So what we're going to do is roll on through. 25 squared equals h squared plus 20 squared. We do all that out. We should come up with h squared equals 225, and that should give us a height of, if you do it on the calculator, 15. So this thing is 15 feet tall. We got a base edge of 40 feet. That should be all we need. Remember that volume is 1/3 times base area times height. The base area, I think you guys can see, this is a square, so it's going to be 40 times 40. And then we're going to multiply by the height, which is 15. So we do 1/3 times 40 times 40 times 15. And that gives us 8,000. Let's move on to cones. Here's why that 1/3 is important, because it comes back. So the volume of a cone is also 1/3 times the base area times the height. Now, because this is a circle down here, we have a specific area formula for it. So another way to write that volume formula is 1/3 times pi r squared h. And if you go back and check the cylinder volume formula, it's actually this part. So the only difference between a cone volume and a cylinder volume is this 1/3 out front. Okay? So, finding the volume of a cone. Let's look at this TP problem. So, what we have is a TP that is 12 feet high, has a base diameter of 14 feet, so I know the radius, half of that is going to be 7 feet. And we're looking for the volume of, this is approximately a cone. It's probably more accurately sort of a pyramid, since I see flat lines between these poles. But this is fine. We can use a cone to approximate the area. And we're just going to use our formula. So 1/3 pi r squared h. Remember we said r was half the diameter, so that's 7, and the height is 12. And now we just multiply everything out, and we get something about 616 cubic feet. So again, I think you guys have heard me say this before about this unit. This is very formulaic, right? We take a formula, we plug in numbers, we find an answer. That's really all surface area and volume are. I mean, there are some problems where you have to get creative with them, but most of the stuff we're going to see and be assessed on, not going to get all that complicated. We are going to look at, for a second, an oblique cone. Now, I bet you guys are looking at this thinking, oh, it's so much more, it looks totally different than all the other right cones we've seen, right? You notice that the point is not directly above the center. That's weird. We do have a height, and we do have a diameter, so actually, it's no different. We are using exactly the same formula. Notice that r is still going to be half of the diameter, which is given here. So r is going to be 15. H is going to be 25. Plug in those numbers, and we get 1875 pi, which is approximately 5,890 feet cubed. I want you guys to look at the bottom. It gives you two ways of writing that answer. You could write it as exactly 1,875 pi feet cubed, or approximately 5,890 feet cubed. Okay, so there's kind of two options there. You can write it in terms of pi, or you can write it approximately with the by multiplying out that pi. That's all for today. Homework 90 should be due next time. This is going to be from page 1670, number 11, and from page 1671, numbers 13 and 16. I'd also like you guys to look over the 11-6 slides. Those are going to be on surface area and volume of spheres for next time, which will be our last material covered before we do our review and then our unit test. So I'll see you guys next time, and good luck.